Hello, my name is Gabriel and welcome to a new video of the series for concierge. Yesterday we left off after running the suite of tests for different guests, and as we could see at the end of the video, the performance was horrendous. It ran, but it was super bad performance-wise. We had a bug for time sent, time received. I have fixed it. I did go and do some refactoring meanwhile to split the page in multiple components and have a header. And the performance when comparing two results here has been improved dramatically. Later on, we'll validate these requests. Now, what we want to do today is keep the same model, but try to optimize the prompt, the system prompt and the user prompt, such that we actually do hit some cache and things run faster. So our first idea would be to keep the system prompt as it is, because it is kind of general and can be applied to multiple pages, but move this part, move the data before the customer name, and can do like this. Here is the list and find information about this customer. We should also do this. So this is the first idea, a friendly name of this. Data before customer name, and let's start the test. Let's also bring vllm. Okay, here we have vllm logs window. A little bit. So the first prompt processing has happened, and now we expect the KV cache to be hit more and more. It's on subsequent requests, and also the prefix cache should improve. Another thing that we can improve later is to see how long the combination of system prompt and user prompt are in terms of tokens, and use the context length when we start the model, which is maybe twice as long, but free up more VRAM. Like this, when we run parallel requests, they will start being accepted faster, because there will be enough space in the VRAM for two concurrent requests. If we look at yesterday logs, the maximum we hit was 61, maybe 62%. Another improvement we'll do, this approach seems to be working. On the second request, we start with 60% KV cache hit. This is great. And prefix cache hit, it's increasing also. The prefix cache hit cannot go super high at some point because there is variation in the customer name. Also, in our case, as we can observe from the second request, this approach is actually significantly better than what we had the first day when we were sending the same guest name all the time. This is very interesting. The reason why this is happening is because cache is sequential, so to speak, from beginning to the end. So the higher we move the information to be searched into, the sooner it will be utilized, and the sooner the model can go further into token generation, into the second phase. So this is the explanation. However, we cannot really move all of it in the beginning. On other pages, we might give another prompt, and if we change the prompt that we have here on line number 38, these lines number 36, 37 should be high enough, but still we have to keep in mind that 37 will be regenerated a few times. So every time we do an update on a reservation, on a room, or in the customer information, this 37 will be dynamic. Now, what we can do is arrange what goes into this 37. We will try this later. We will try to first put the rooms, then customers, and then reservations. The reason being is that when you create a reservation, you don't change the room. The room belongs to the hotel. That one stays the same no matter what. Then you don't change your person. It's very unlikely. Maybe you change it once when you check in because you add some allergies or something, but you can change the reservation. If you are moved to a different room, your reservation changes. If you are extending the period because you're buying more days, your reservation changes. Let's say the hotel offers a bar and where you buy products. Again, the reservation changes. So by structuring the information which goes into line number 37, we can have some control. Another idea, it is to print how 37 looks like and then optimize it. We can try different optimizations. We can try XML, we can try JSON, we can try CSV. Different models react differently to different type of information because it depends a lot on how they were trained. So our cache is between 60 and 61.8. This is good, and the prefix has actually increased. We started with 6.2, now we have 6.6, very good sign. So I expect the other responses to be in the same range, which is very good. So our concurrent requests have started, and as we can see, the cache hit has increased significantly, and the response times have increased. But what is more interesting is that they are kind of in line with the sequential ones, and they are faster than what we had a couple of days ago. So this is a great improvement. We'll keep working on this. The XML functionality has been finished. We have also added a new button in the interface to generate XML. By pressing this button, this document is being generated, but without the formatting. We have rooms on top, and then we have guests. On guest level, we have the fields that exist in the database, and then there is a reservation. On reservation, we have the fields from the reservation. Probably this could be improved if every guest has just one reservation. By looking at the data, we could duplicate this into 4 different rows. We don't know what is better and what is worse. We will test. Right now we know how the XML will look like. Actually, it will look like even better than this. Here it has a size of 311 kilobytes, and if we regenerate it, now it has a size of 260 kilobytes. That is because it has no formatting. So if we open it, it's just one line of text. But another thing that we could do, and we will test, what happens if we mark the XML. Will this trigger a different layer in the LLM or not? This is to be tested later. So right now we have the XML. So the comparison that we'll be doing now is all the JSON versus the XML. So everything has been saved. Let's run the test. We know for sure that the first one will be slow because the cache has been invalidated by coding, but it will catch up really fast. Here's vllm. Personally, I expect the results to be slightly faster than JSON, but not by much. At the first glance, the cache hit is significantly better, but this can be two things. Either the string is longer and more characters match, or the string is significantly shorter and the percent of matches is higher. So far, it seems that my theory was wrong. XML, it is slower than the other JSON implementation we had. On the other hand, it is more consistent. The deviation between the slowest and the fastest answer for sequential is smaller. For concurrent requests, it seems that all of them are going in the same time. This is a change from first day when the first one was starting and the other 7 were waiting, and then they were retrieving the same information. A maximum cache hit for concurrent requests with JSON was 72%, and then as the requests finished, it went back to 62. Here, it behaves differently actually. It starts with less, 63, and increases. It is much better for concurrent requests. For sequential requests, the difference between the slowest after cache calculation and the fastest is very small. In the case of the JSON, the difference between the slowest excluding a build is very big. And in the case of difference between the slowest and the fast is really big. It's almost double. So for consistency, I think the XML is better, but overall, it's very obvious that it is slower. Another part which can be optimized is for rooms to include the allowed booking channel. Then we will save a lot of tokens on this part, which is duplicated. So they can be grouped by booking channel. Or probably same can be said for guests. If we would group the guests by the status of the reservation, then we can save a lot of duplication. However, the pitfall with this approach is that we are starting to hyper-optimize for this particular use case, and this is not the use case in general. We want to have a generalistic system which receives an XML such as this one, and then can perform whatever query the prompt. So the user can write a prompt, and then based on this structure, we answer to the user. This is optimal for us because we are searching for guests, but if we were to be searching for reservations or for statuses or something else, then our current structure may not be optimal. There is also a thinking part of the model. And in that part, the model retrieves the information, but then it needs to rewrite or talk with itself, let's say, between the layers and reorganize the information. It can be the case that if the information is already organized in an optimal way, it has to do less of this internal conversation. And this internal conversation is this part here with token generation. So it can also be the case that the less token generation we have to do, the more seconds we save. Let's try what happens if we mark the data as special string. Is it faster to retrieve it? The generation will look the same, only the prompt that goes to the LLM will be different. The first result came in and it was 252 seconds versus 251. So adding special characters to signify that this is the data structure did not seem to add any meaningful difference. We will see later down the line, maybe there are surprises. The results came in and it is quite interesting. By adding these special characters, we have managed to keep in the context and we have managed to narrow significantly the delta between the slowest and the fastest response, and all of them seem to be very grouped. Now, the next idea is to re-implement and use a CSV instead of an XML, but we will still keep the special characters to be very specific about which is the data and which is the prompt. Let's refresh the page, generate the file once more. The CSV is half the size of the XML. New test suite. Let's run the test once more. The results for CSV came in, and what is interesting is that the delta for duration is way tighter than in the case of the XML. However, if we look at the results for sequential, they are kind of missing. It's just the beginning. And then for concurrent, they seem to be trimmed. So it is possible that the max tokens are not enough to analyze the whole CSV. Let's try with adding another zero, like a lot more, because on disk there is a big difference between the two files. The CSV is less than twice as big as the XML. So theoretically, if we manage to keep the processing speed of the CSV, the consistency, and get the correct response, probably the CSV is the way to go. So I run the tests again, but with longer context, and see what happens. Tests for the longer context size have finished, and the conclusion seems to be interesting. For sequential tests, some of them were actually a lot faster than before. Before, all of them took 201 seconds. Now we have the third guest, which is 147 seconds. This is on par with the initial JSON results. For concurrency, we kept about the same speed, 286 versus 285, with the exception of the second guest with 270 and first one 265. Now, if we look at the data, this was no response. So we have some that finished correctly and most did not finish correctly. So we can conclude that using a CSV is not a good idea, and using the JSON seems to be the fastest. However, it has the biggest discrepancy between shortest and longest run. Using an XML while using the special characters has better consistency and returns just one error. And without special characters, it returns also one error. So for now, JSON is the best. We will split this video in two parts because we can also send information as a file according to the OpenAI documentation, and it is possible that will make a difference. Thank you very much for watching, and see you in the next one.